Hello, welcome everyone to the group exhibit Hydrogen Fuel Cells at Hannover Fair 2012. Please come in, sit down, drinks are on the house, and hope you enjoy this talk. It's on the ZSW Fuel Cell Test Center. With me today I have Dr. Alexander Kabza. He's the director of the center. Please join me in welcoming him. So, welcome.
Thank you, Christine. Good afternoon, ladies and gentlemen.
So could you please, to start, to give a bit of context, could you please tell me a little bit about the ZSW in general and your department more specifically?
Okay, the ZSW is a non-for-profit organization located in southern Germany. We have two locations, working on one hand photovoltaics, on the other hand on energy conversion, electrochemical energy conversion. This is mainly batteries and fuel cells.
How many years have you been running this?
We are operating now this fuel cell test field since about 12 years. So we have a lot of experience doing customized fuel cell tests and fuel cell system development and testing.
Okay. And I believe you work both with industry and public funding?
That's right, yeah. We do have a small base funding from our local government, it's about 10 to 20%. And the rest of our money is coming from direct projects. This means about 50% from public grants and the other 50% from direct industrial cooperation.
So this structure where you're funded both by industry and by public money, and it allows you to be not-for-profit and independent, what kind of advantages does that give you?
Yeah, thank you for really talking about this. We are independent. That means we are not preferring different customers. We have the possibility to test stacks and test systems on our test stands. We are operating this fuel cell test field, as I mentioned, since about 10 years on a lab area of about 600 square meters. We have about 20 fuel cell test stands in operation where we are able to test fuel cell stacks and fuel cell systems from a power level from about 5 kilowatt up to 50 kilowatt.
So being independent, you can have anyone come in, it doesn't matter where they're coming from, and you'll give them non-biased results back about their products.
Yeah, so anyone who has interest in testing his stack, his system, an independent research organization can come to us, can visit us, can see what we are doing there. And there are, of course, a lot of different test opportunities that we have here in-house. We are able to do performance testing. We are able to perform base characterization, durability testing, accelerated aging testing under fully dynamic operating conditions. So that's very depending on the stack design and very depending on the customer specification regarding his product.
Do you have a particular cell architecture that you specialize in?
Yeah, from the history, our focus is on the low temperature PEM fuel cell. That's where we have a lot of experience, but since a couple of years we are also working on the high temperature PEM fuel cell, which is operated at about 160 degrees C. But as soon as we are going to systems, we are there more or less independent of the fuel cell technology. That means we can really test also SOFC, PEM-FC systems independent of the base fuel cell technology.
At the systems level, then, what equipment, characterization equipment do you have? What are normal tests that you carry out?
So we are having also a little bit based on our history, the capability of testing stationary power plants. That means natural gas coming in, electric power is coming out. But since about 5 years, we are really more focusing on the automotive industry. That means we have an automotive test platform established here since last year where we are able to characterize fuel cell stacks for automotive application under fully dynamic operating conditions on the test stand level but also on the system level. This gives us the opportunity to not only test fuel cell stacks under fully dynamic operating conditions but also system components, humidifiers, blowers, valves, sensors and so on, where we are quite flexible because those systems are of course not highly packaged, and so we can integrate different components into this system.
Okay. I understand you offer also certification testing.
We are able to do this certification testing based on our quality management system, which we established 2.5 years ago in 2009. It's based on the 9001 quality management system. So we have established all these calibration stuff, all the documentation, where we can really provide this certified testing based on those state-of-the-art fuel cell normative documents, which are nowadays available.
Okay, so you're speaking about the IEC 62282.
Correct, yeah. But this is one example. There are other possibilities also, and it's partly very depending on the customer specification, on the customer request, what he would like to have tested, if it's an dynamic operating condition testing or if it's a stationary durability run. So that's on one hand very challenging to provide all these wide range of possibilities, because no customer is like the other, and also the requirements that the customers have to us can vary from really base performance characterization up to an accelerated lifetime testing for several thousand hours.
What happens when a customer comes to you and says, I have a fuel cell and I want to test it, but I have no idea what to test? Where do you even start?
Yeah, first of all, we should check if the customer has already some experiments in fuel cell testing, if he has some know-how based on the testing in-house, or if he's really starting having a product but having no possibility to test this component in-house. Yeah, first of all, we have to figure out the objective of this test, if it's a durability test or a performance test. Then we are talking about some load profiles, for instance. We should define the operating conditions, temperature, gas, quality, and so on and so on. Then we check our availability of fuel cell test stands, and then we can go ahead, start testing, delivering the test results to the customers.
So you're very flexible about what you can offer?
Yeah, as I mentioned, we have about 20 fully operational fuel cell test stands. They can be run unattended. That means 24 hours, 7 days a week. That makes it very cost efficient for our customers to let their objects test here at the CSW, efficient regarding operating hours versus calendar hours, and that's also very cost efficient. And on the other hand, we have an electric workshop and a mechanical workshop here at the CSW, so we always, not always, but very often have to adapt the specific test stand hardware to the specific requirements from our different customers.
About the operation where you operate 24/7, you were telling me about one particular cell that you were running, or stack, sorry, I believe, that you were running for how long?
They were running for more than 20,000 hours. This was one stack that was designed for a stationary power application. 20,000 hours are about 3 years continuous operation. This is very challenging, first of all, for the stack itself, but also for the test center, for the infrastructure. We are able to do this. This can be only done if you are really able to operate your facility unattended. And of course, there are shutdowns due to public grid issues and so on. But more or less, those 20,000 hours were performed within about 23,000 calendar hours. So this is cost efficient, and we are able to get real operating conditions on our test objects as good as possible. And the benefit to, for instance, having vehicles on the road is that we are able to repeat the tests again and again, and having really repeatable results, and the results can be used for doing simulations, for instance, for doing further development on their specific products.
Great. So is that some sort of record, how long you've been able to run it for?
Yeah, the objectives from the DOE are about 40,000 hours for the stationary application and about 5,000 hours for the automotive application. That's very depending on the operating conditions. On one hand, stationary is more steady state. On the other hand, the automotive is more dynamic. And if you don't know what you're doing, you can really destroy a stack within seconds due to higher pressure, due to strong voltage cycling. You can age a stack within hours. And the objective of our test is to be as realistic as possible and to help the customers to understand their product regarding aging, regarding performance, and to make also suggestions regarding operating conditions, regarding optimization of flow fields, and help the customers to really improve their products.
Okay. The other number that kind of interested me when we were talking previously is you've measured an incredible number of cells, individual cells from different people.
Yes, so first of all, we have our own stack database where we are having different stacks in there, and this number is about 700 nowadays, so that means we built at the CSW about 700 short stacks from various active areas, starting with 50 square centimeters, going up to 560 square centimeters. We were integrating different components from different customers with the objective of testing those specific stack components in the CSW stacks. But also, as you mentioned, due to the high amount of industrial projects, we tested many different stacks here in-house, from stationary application, portable application, up to full-size stack automotive application going up to 100 kilowatt. So there's a huge amount of experience on different stack designs here available.
So you've seen everything that can go good and go wrong.
I won't say everything, but a lot. Yeah, thank you.
Okay. Before I continue, I wanted to give the audience an opportunity to ask a question.
Thank you very much. Dr. Kabza, it sounds like you actually run a small power station with all the fuel cells that you have running at any one time. What do you do with that load? Do you return it to the grid?
Actually, no. We are normally using electronic load banks which are converting the electric energy to thermal power. Of course, there are liquid-cooled systems and water-cooled systems and air-cooled systems, so we are not using the electric energy, but using the heat.
At least it's not wasted. Anybody else while I'm down here already? No, if not, I'll give you another chance at the end. So think hard. If you have anything specifically you need to test, this might be the guy to ask. Right. So, but you brought something special with you today. Could you please tell me a bit more about this?
Yeah, so what you can see here is, first of all, an fuel cell stack which has some inputs and outputs there. That's the big difference between a battery and a fuel cell. So the fuel cell itself is a multimedia system. We have some in and outputs, and that makes it a little bit more challenging testing a fuel cell compared to a battery. On a battery side, you have more or less just the electric connection. On the fuel cell side, you have to provide the fuel gas and the oxidant gas, air, for instance, and you have to cool down the stack or to keep it at a specific temperature. You have to measure the single cell voltages. What is new on this stack design here, it's an CSW design. It's based on an automotive specification requirement. This fuel cell stack has an active area of 300 square centimeter, and the power density is from the bipolar plate here. This is a 5-cell stack. It's about 3 kilowatt per liter. So that's quite a huge amount of electric power which can come out of this automotive stack design.
And why did you choose to design this stack?
Yeah, so this system helps us, first of all, to demonstrate our knowledge in stack design. We do have 3 groups at the CSW in Ulm working on fuel cell. One group is more working on the fundamentals. The second group is doing some stack design, providing service activities for our customers to really go ahead with their development on the stack level. And the system, the third group is my group, which is doing the service for testing and system development. So what we can do here is, first of all, use this test as a flexible test platform where different customers that have fuel cell systems in their business, they can send those components to us and we can test this components in an automotive stack design with a very high flexibility, and the customers can back the measurement results and can also make some benchmarking to different components which are available on the market.
So what customers might be interested in this platform?
Yeah, first of all, from the stack level, there are those customers that have an MEA, for instance. MEA stands for membrane electrode assembly. That's the core component of the fuel cell, or gas diffusion layer, or bipolar plate material. So we can provide this design to them to manufacture their components, which we can integrate in this stack and do benchmarking compared to other components which may be placed in one single stack compartment.
And the ability to do this is unique within Germany, isn't it?
Yeah, we are trying to close the gap because there are international players available which are doing development in automotive stack design, but no one, as far as as we remember, in Germany. So we are trying to close the lab. It's based on a European project, this development here, and our objective is not to sell at the end automotive stacks, but we are trying to develop them and support different players here in Germany to go ahead developing automotive stack components at the end of the day.
So why do you think no one else in Germany has offered a service like this?
Yeah, it's a good question. Maybe the global players are too strong. That's maybe one idea. They are really maybe far ahead from this development here. But the benefit that we have is that we are having, or we are able to provide, a very flexible service for placing different components here and also component mixtures. We call this rainbow stacks into one component and test this really independent due to other global players which are available there on the market.
Okay, thank you. Does anybody else have any questions to that? Maybe someone who could use that platform. Right, well, I'm sure you'll find, standing next to it, this lovely platform, I'm sure you'll find someone here at the exhibit that
hopefully
will take advantage of it. Thank you very much for coming, and I'm sure and thank you the audience as well for paying attention. If you have any more questions for him, he will be at booth D50 for the rest of the exhibit. That's just over there if you're looking. So thank you very much.
Thank you for your interest, and see you later maybe. Thank you.
And sorry, if you'll stick around, we have another interesting talk all day, every day here, but the next one in particular is with Dr. Alexander Dyke, that is on the subject of material development for fuel cells applied to CHP heating systems. Thank you very much.